Hi, everybody. Today we are looking at probability range, and on Wednesday we're going to look at tree diagrams and outcomes, and that will pretty much wrap up our math unit for this year. So, for today, we're going to look at what's called theoretical probability. Now, theoretical probability just means that it's what should happen. For example, if I flip a coin 10 times, 5 times it should come up heads, 5 times it should come up tails, because there's only two choices. Realistically, we know that there's probably going to be a variance of that, and we might have 6 and 4, we might have 3 and 7, but theoretically, if we tossed that coin an infinity number of times, half the time it should turn up heads, half the time it should turn up tails. And that's what theoretical probability means. So when we have our formula for theoretical probability, we talk about our favorable outcomes. Our favorable outcomes are the ones that we want to happen. So if I was rolling a die and I wanted to roll an even number, my favorable outcomes would be the numbers 2, 4, and 6. So that would be a total of 3 favorable outcomes. Now, when it talks about total possible outcomes, that means what are all of my chances? Well, all of my chances, there's 6 faces on a die. So my total possible outcome is 6 chances. So what is the theoretical probability of me rolling an even number? Well, we've done percents 1,000 times, top divided by bottom, times 100 would give me a total of 50%. So I should roll a even number 50% of the time. Theoretically, that's what should happen. Now, when we speak about theoretical probability, we also talk about things like, is it possible? Is it impossible? Certain, not certain. So for this little graph here, I've shown impossible, it can't ever happen, and certain, that it will almost always happen. And I'm just going to erase this up here for a second because I haven't used that function before and I didn't realize it stayed on my screen. So if we look at, for example, if I say, what are the chances, what's the probability that Wednesday will happen after Tuesday? Well, we know in our universe, in our galaxy, in our time dimension, that Wednesday always comes immediately after Tuesday. So that would be 100% or certain probability, or we say it has a probability of 1. If we're talking about things that are impossible, if I said that we were looking at the numbers 1 to 10, and what are the chances that the number 300 would be in the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Well, that would be impossible, 0% or 0 probability. So when we're talking about probability, we're looking at this difference between 0 and 1, or 0% to 100%. So let's pretend that our basement flooded. Not a great thing to pretend, but that's okay. So our basement flooded and we had our soup cans on the floor in the basement and all their labels fell off. All we remember is that we bought 2 chicken soup, 3 celery soup, 4 vegetable soup, 5 mushroom soup, and 6 tomato soup. The problem is we don't know which is which anymore. So if we look at the first question, what is the probability of each event? What is the probability of vegetable soup? Well, I know that there were 4 cans of vegetable soup. So I put there are 4 cans of vegetable soup. Then I find out there are 20 total cans of soup. Well, how did I get that? Well, I added 2 chicken plus 3 celery was 5, plus 4 vegetable was 9, plus 5 mushroom was 14, plus 6 tomato was 20. So I had 20 total cans of soup. So again, I go back to my formula, and I like to do this probability of vegetable. Why do I put that there? You can even put a V for veg or just veg, but it helps you remember what you're looking for because things with probability can get a little bit tricky when we start looking at several outcomes at once. For example, what would be the probability of me rolling an even number on a die the first time, an odd the second time, a 2 on the third time? So if we keep our information, my number one favorite word, organized, it helps keep our brain organized. So we have the probability of vegetable soup, favorable outcomes, and I looked up here at my graph and it told me there was 4 favorable outcomes. So that was 4. And there was 20 total cans, so that's 20 possible outcomes. So if I was just going to blindly choose one of those cans of soup, I have a 25% chance of getting vegetable. Now, that also means that I have a 75% chance of not getting vegetable. But you see my point. So next I look at what is the probability of getting beet soup? Well, the probability of beet soup is 0 because there was no beet soup in our list. So the probability of 0 over 20 is 0%, just like the probability of us getting turnip soup or the probability of us getting squash soup. None of those things were options, so our probability is 0. What is the probability of getting a vegetarian soup? And here we're talking about vegetarians, not vegans, for all of you who are going to say, well, what if it's got this? What if it's got that? I'm saying that just the main ingredient is not meat. Well, I have, if I'm going to scroll back up, I have 3 celery, 4 vegetable, 5 mushroom, 6 tomato. That's where these numbers came from. I still have a total number of cans of 20. So I have 18 out of 20 cans I will consider vegetarian, which means that we have a 90% chance of getting soup that is not meat-based. Now, we all know that if we had all those cans sitting in front of us and we all said, oh, the last thing in the world I want is to eat chicken soup, that chances are we're going to be unlucky and grab the chicken soup. But theoretically, you have a 90% chance of choosing something else, only a 10% chance of choosing chicken. All right. I think that's pretty self explanatory. Let's look at likely outcomes versus unlikely outcomes. So, what is the probability of December coming after November? Well, on our calendar, in this galaxy, in our universe, you understand what I'm saying, it is 100% likely that December comes after November. What is the probability of rolling an even number on a die? Well, that's what we just looked at the very beginning. We had a 50% probability. So I would mark B here and say that is B. Sorry, my trackpad's not working so well here. So this was A. This was B. The probability of it being warm in January, and I'm talking about in Smithville, not in Hawaii, the probability of it being warm in January, well, it's going to be unlikely, but we can't say 100% unlikely. We've had some Januaries where it's been pretty darn warm. So I would say as long as you're somewhere close to unlikely, but not right at unlikely, unlikely means it's not going to happen, then you're going to be fine. Anywhere in this range here. Finally, the probability of Mrs. Spherical becoming an astronaut. Well, I can tell you that the probability of Mrs. Spherical becoming an astronaut is D. unlikely. It is not going to happen. A, Mrs. Spherico's too old. Mrs. Spherico's body is not in any shape to be going into outer space. And Mrs. Spherico is not really happy with the probability of a safe flight travel. If we look at all the space flights that have happened and the number that there have been problems with, the number's too high for Mrs. Spherico. I am not going to be an astronaut. I'd like to pretend, but it's never going to happen for me. Maybe one of you guys. All right, so let's look at some problem solving words with this. So I hope Josh Carter's on because I wrote this question about him. This summer, Josh is working at a call center selling magazine subscriptions. If anybody in our class could sell somebody, it's a magazine subscription, it's Josh. He would just make us all laugh and we'd say, hey, you're a great guy, we'll buy your magazine subscription. So in any call job, we know that people are going to hang up on you and people are going to say no, and some people aren't even going to answer their phone. So for every 400 calls Josh makes, that's a lot of phone calls. So for every 400 calls Josh makes, he's going to get 88 people. So 400 calls, he's going to get 88 people saying, sure, Josh, you're a great guy. I want to help you out. I'm going to buy your magazine. Josh says, woohoo, puts the little tick mark, sends out his information, and wants them to send their money. So what Josh realized is, though, that even though 88 people out of the 400 say, yeah, I'm going to buy your magazine, only 80 of them actually pay for the subscription. So 88 people out of 400 say, yes, I'll buy your magazine, but only 80 really do. The other 8 just never send in their credit card information. So we look at what is the probability someone will order a subscription. Well, probability of ordering is favorable over total. Like always, you get marks for showing the formula. The probability of someone ordering is 88 over 400. I pull out my handy dandy calculator and I do 88 divided by 400 equals 0.22. We know we multiply that by 100 and we get 22%. So Josh would be considered successful at his job if 22% of the people he called said, yes, Josh, I will buy your magazine. Then we look at what is the probability that someone's going to pay for that. So we know that the probability of paying for their order is favorable over total. Paying for the order is only 80 over 400, which drops down to 20%. So Josh is successful at his job if 20% of the people buy his magazines. Now, hopefully Josh gets paid a lot to do this job because that seems like a lot of hang-ups to me before Josh makes any money. All right, next we're going to look at Olivia and Cameron. And Olivia and Cameron are going to play a game. To see who goes first, they're going to roll a die. If Olivia rolls a 4, what is the probability that Olivia will go first? Let's assume that the lowest number is the number that gets to go first. So Olivia rolled a 4. So now it's Cameron's turn to roll. If Cameron rolls a 1, a 2, or a 3, sorry, I'm going to change it to the highest number. If Cameron rolls a 1, a 2, or a 3, that's favorable for Olivia, 3 outcomes. The total are 6, so she has a 50% chance of going first. What is the probability that Olivia will not go first? Well, if Cameron rolls a 4, a 5, or a 6, and we have our total favorable over the total number, again, we have 3 out of 6. We can't say that she's okay with the 4 because if they tie, they're going to have to roll again. So if Cameron rolls a 4, a 5, or a 6, That means Olivia will not go first. You have to watch the wording of these questions. That Olivia will not go first is also 50%. So, what is our probability of a reroll? Well, the only way we're going to have a reroll is if Olivia and Cameron both roll a 4. So we have our total favorable over our total outcomes. And the only probability we have is the number 4, which is 1 out of 6, which translates to 16%. So there's a 16% chance that Cameron and Olivia would both roll a 4. All right, that's it for today. Tomorrow we're going to be doing something a little bit different. Tomorrow we're going to be doing, I guess you could call it a partner project. If you are interested, you can either Skype or you can Zoom or FaceTime with someone else to work on this project. I will tell you, it's a little bit tricky. If if you want to try it on your own, that's fine as well. But it's looking at probabilities and it's looking at a die or a dice. But like I said, I would say you could work in groups of up to 4 people. If you could all Zoom at the same time, that's fine. Or if you want to work on a Google Doc at the same time, that's fine. Doing it on your own is also perfectly fine. All right, everybody. I will see you at 1 o'clock today for our Google Meets. I hope everyone has an amazing day, and I will see you later on. Bye bye.